You can relate data centers to human bodies. When we heat up, when we exercise, your body can't maintain that level of heat. You do have to either slow down or cool yourself off. When we are exercising under stress and under heat, a fan can help us, but it's not gonna be the best form to cool yourself down. And that's why a lot of people, when you think about they go exercise, they come and they take a cold shower, because that ultimately is more effective than just putting a fan.
If left unchecked, you can have a heat stroke, and what it means, your body is just shutting down in a way that is forcing you to cool. Now, if you think of a data center, it's very much the same, except that it's much larger. When we're talking about power densities in hundreds and thousands of amps concentrated in a very small area. So when you're moving heat at that scale, the only answer physics will allow is liquid.
Data center power is increasing year over year, and certainly when you think about it from a decade ago, it's increased 4, 5, 10-fold. And the AI is really the catalyst, right, for the change. When you think about the way that we've been cooling historically with air, it just really cannot keep up with the AI power levels that are needed.
Air cooling has a certain limitation of how much heat you can actually extract, because the thermal capacity of air is much lower than the thermal capacity of a liquid. If you have liquid cooling that's directly in contact with the processor, you can actually get maybe 10 to 15 or 20x more efficiency in the extraction.
The GPUs that are in there, if they are off in terms of what temperature they're running at, their performance is compromised. And that's why it's extremely critical that we manage the heat very effectively through different cooling methods.
We look at a data center in a very holistic manner. Be efficient in your power supply, and then sense what's happening at every rack and every server, and actually actuate through our motors.
TI being able to address the entirety of the cooling for a data center, I think just speaks to the breadth of the portfolio that we have. The sensing element, the motor drives, the compute that we have, and power capability, it really just cannot be matched in terms of the breadth that we have to cover every element of the cooling.
The close connection between our analog portfolio, our digital portfolio, and our long history of working through building automation and power delivery system should be actually putting us in a very good spot to solve the data center challenges of today and of the future.
We're never going to be satisfied with the power capability or the power performance. We're always going to strive for more.